Hello! In our last discussion, we explored algorithms. An algorithm is a set of step-by-step instructions for solving a problem. Think of it like a recipe for baking a cake. You have a list of ingredients and a sequence of actions. Mix the flour and sugar, preheat the oven, bake for 30 minutes. But how do we give these recipes to a computer? A computer does not understand English or any other human language. It needs a special kind of language, designed specifically for it. This is where programming languages come into play. They are the essential bridge between human ideas and computer actions. A programming language is a formal language, a set of instructions used to produce various kinds of output. At the very core of every computer is the Central Processing Unit, or CPU. The CPU is the brain of the operation, but it speaks a very, very simple language. This language is not made of words or letters. It is made of electricity. Specifically, it understands only two states, on and off. We represent these two states with the digits 1 and 0. This system is called binary. The language it forms is known as machine code or machine language. Every single instruction must ultimately be a sequence of these binary digits. Imagine writing a recipe using only two symbols, 0, 1, 1, 1, 0, 1, and then 0, 1, 1, 11. 1100, 1, 0, 1, 0, 0, 1, 1, 1, 1, 1, 0. This is what early programmers had to do, manually input long strings of ones and zeros. As you can imagine, this was slow, tedious, and prone to error. A single flipped bit could ruin the entire program. Finding that mistake was like searching for a misplaced grain of sand on a vast beach. The advantage of machine code: it is the only language the computer understands directly. No translation, maximum speed. However, it is unreadable and not portable between processors. The next major breakthrough was the development of assembly language. Programmers replaced cryptic binary strings with short, memorable words called mnemonics. Instead of remembering a code for addition, write add. To move data, write move. It introduced a layer of abstraction that made programming manageable. Each mnemonic corresponded to a single machine instruction. A special program called an assembler translated mnemonics back to ones and zeros. Programmers could think in operations like add, subtract, and load. Assembly's main advantage was readability while retaining fine-grained control for highly optimized code. But it was still not portable. Intel assembly differs from ARM, so programs had to be rewritten. It established translating a source program into an object program, paving the way for high-level languages. The next leap would finally free programmers from hardware constraints. BASIC, COBOL, Pascal, Ada, C, C++, Java. Languages to focus on the problem, not the hardware. Example: input two numbers, add them, and print the result. A task far simpler to write in high-level code. The true revolution came with the invention of high-level languages: Python, Java, C++, JavaScript, designed to be close to human language. They use familiar words, mathematical symbols, and logical structures. For example, O's A plus B. High-level languages abstract away complex hardware details. Portability is one of their most powerful features. A single high-level statement can correspond to many lines of machine code. Write once, run anywhere. Easier sharing and higher productivity. They let programmers focus on solving the problem instead of managing memory addresses or CPU registers. The main disadvantage: being removed from hardware can reduce low-level optimization. Handcrafted assembly can be faster or smaller. For most applications, the trade-off is worth it. Today, operating systems, mobile apps, and websites are written in high-level languages, enabling systems once unimaginable. If a computer only understands machine code, how does it run a program written in Python? It needs a translator. Two main types bridge this gap: compilers and interpreters. Compilers are like a translator who converts an entire book before you read a word. It reads your entire source code at once, checks errors, and optimizes. Then it outputs a standalone executable of machine code. Advantage: speed. Disadvantage: development can feel slower due to recompiling after changes. Examples include C, C++, and Go. Interpreters are like a live translator for a conversation. They take your code one line at a time, translate it, execute immediately, then move on. Advantage: flexibility and easy debugging. Errors stop on the exact line. Downside: generally slower than compiled programs. Examples: Python and JavaScript. Many languages use a hybrid. First compile to bytecode, then run on a virtual machine. Java and C# take this approach. Result: portability with good performance across platforms. Whether compiling or interpreting, translation runs in phases: lexical analysis, syntax analysis, semantic analysis, and code generation. The first phase is called lexical analysis. A lexer reads your source as a stream of characters and groups them into tokens. For example, price, no, 10, price, identifier, MAO, assignment operator, 10, number literal, statement terminator. Next, syntax analysis or parsing. Tokens are organized into a parse tree or abstract syntax tree. This phase checks grammar, required semicolons, and matched parentheses. If you write 10, price, it flags an error. You cannot assign to a number. Then, semantic analysis. It checks program meaning, type checking, and scope rules. The analyzer annotates the tree with types and symbols. Finally, code generation. The verified annotated tree becomes the target language, machine code for a processor or bytecode for a VM. The code generator emits efficient instructions: characters, tokens, parse tree, machine code. This pipeline is the hidden magic that brings your code to life. A programming paradigm is a style or way of structuring programs, an approach to solving problems with a language. Different languages support different paradigms, and some support multiple. There are 4 major paradigms to know. Procedural. Think of a program as a series of steps or procedures executed in order. Key feature: the procedure or function, a block performing a specific task. Break programs into smaller, reusable procedures. Languages like C and Pascal. Object-oriented, bundle data and the functions that operate on it into objects. Objects have properties, data, and methods, functions. Example: a car with color and speed, and methods like start engine and accelerate. Languages like Java, C++, Python. Functional. Treat computation as evaluating mathematical functions. Avoid changing state and mutable data. Pure functions return the same output for the same input with no side effects. Haskell and many others, including JavaScript and Python, support this style. Declarative. Describe what you want, not how to do it. The system figures out the steps. A key example is SQL. Select name from users. Where country, Josh, Canada. You declare the result you want. HTML is also declarative. You describe a page's structure, not the drawing steps. No matter the language or paradigm, a few fundamental concepts appear everywhere. The building blocks of programs. Identifiers are names you give to things. Variables, functions, classes. Good names make code readable. Data types classify values and allowed operations. Integers, floating point numbers, strings, booleans. A variable is a named container whose value can change. A constant is set once and never changes. Useful for fixed values like pi. Literals are the raw values written directly in code. Input and output connect programs to the world. Read from users' haunch files, print, save, or send results. A basic program. Ask for 2 numbers, add them, display the result. These core concepts, identifiers, types, variables, and I/O, are the universal grammar of programming. We traveled from machine code to assembly to high-level languages and demystified translators and their phases. We explored procedural, object-oriented, functional, and declarative paradigms. Different lenses to solve problems. Make the concepts stick by using them. Do not just read about programming, do it. Pick a beginner-friendly language, Python. Find a Hello World tutorial and modify it to print your name. Good luck.